What's going on? I hope everybody of you is doing great, nice, and absolutely fine, okay? And I welcome you to JEE English Unacademy. My name is Yawar Manzoor. And hit the subscribe button if you haven't subscribed yet, okay? And press that bell notification so that you'll get the update every single time, all of you. And I just want to know in the live chat if you can see me and if you can hear me and if we are live right now, okay? Yes, absolutely. Okay, what's up? What's up? So, ladies and gentlemen, my name is Yawar Manzoor, and this is a piece of information about me. I'm a JEE Physics expert. The Fury Live is the series that we are running exactly on this YouTube. Yes. So, I just want to know, apart from this, that you can definitely follow me on Unacademy. This is my username because we come up with the special classes every single time over there. So definitely you can join me over there. You can hit the follow button on Unacademy app and you'll basically get the notification every single time whenever we come live. Now the point exactly is now the point exactly over here is apart from this YouTube platform, we teach on Unacademy's own platform. Okay, over there country's top educators are teaching you who are having 20 to 30 years of experience. Okay, now if you people want to learn from those educators, those top educators, if you people want to boost your rank in your upcoming JEE, then I suggest you have to basically take this plus subscription or this Iconic subscription. Now you will ask, what are the benefits that we're gonna get in this plus and Iconic subscription? There are so many benefits. Exactly. Live, you will be getting live classes every single day, weekly tests. Once you are done with the entire stuff that you have studied for the entire week, after that you'll be having the weekly tests. Okay, the structured courses. These courses have been designed by the country's top educators who have got 20 to 30 years of experience. Okay, so these courses are specifically for you people, for JEE people. This will definitely help you in boosting your rank. And this unlimited access means you can create your own batch. For example, if there are so many batches running inside Unacademy, if you people want to create your own batch of your favorite educators, you can select the different educators from different batches and create your own batch. Okay, and this is what we call the Iconic subscription, the golden subscription. In this Iconic subscription, you will be getting all the benefits you get in plus and some of the extra benefits as well. Like you'll be getting personal mentorship. This is personal guidance. Okay, a personal mentor will help you throughout your exam, how you have to handle different situations, how you can exactly crack it. This is exactly you're gonna be getting in this Iconic subscription. So if you people want this personal guidance, then you should definitely grab this Iconic subscription. And you'll be getting test analysis. Means once you are done with your test, afterwards you'll have to analyze your scores, in what portion you are lagging in what portion you need to work more. So that's basically done in this test analysis. Okay, is everybody doing great in the live chat? Come on, I just need to know. All of you can send me thumbs ups, heart, okay, whatever it is. And this experts guidelines, once you are appearing for the JEE Advance, this experts guidelines is highly needed. Okay, it's highly mandatory, because without the proper guidance, without the proper strategies, plans, it is nearly impossible to crack the JEE Advance. So that's why you'll be getting the study material, study planners as well. And now the point is for how much amount of time you can take this plus subscription. You can take it for 12 months, 18 months, and 24 months. Okay, even you can take it for 3 months as well, 6 months as well. You can take it for 3 months at least in the beginning, then see how are the educators teaching you over there. If you like it, then take it for 12 months, 18 months, or 24 months. That's what you can exactly do it. Now, if you use my code, you will be definitely getting the maximum possible discount. Right now, the discount is going on. I'll just tell you in the next slide. Even EMI options are available as well. Okay, this is the EMI option. You can pay it every single month. You don't have to pay the entire amount at once. So this EMI option is definitely available. Next thing is you can take this Iconic subscription for 12 months, for 18 months, for 24 months. Understand? So here also EMI option will be exactly available that you can exactly use over here. Now, these are the batches which we have launched recently. Understand? In which countries top educators are teaching you. If you people want to boost your rank, you can definitely join any of these batches over there. Fine. Next thing is, this is basically what? This is before price hike. This is after price hike. You can definitely check the difference over here. So if you people are looking for taking the Unacademy subscription, Iconic or Plus subscription, I suggest you to basically take it right away, because right now the discount is going on. So go for it as soon as possible. Understand? So this is, you can basically use my code, that is Yawar, in order to get this maximum possible discount. Fine. This is my code Yawar in order to get the maximum possible discount. Fine. Now, if you buy this mega combo, IIT JEE plus CBSE, you'll be getting, for 12 months, you'll be getting 15% plus 10% off. And 24 months, for 24 months, this person 20% plus 10% off. Use my code in order to get this maximum possible discount over here. Fine. Now, this is one of the important slides. I want you people to basically focus on this one. If you people want to learn free on Unacademy, you don't want to pay anything, then I suggest you to go for this biggest scholarship test in India, understand, in the entire country. So this Unacademy Combat, Mega Combat, we call it, you can win up to 4 crore plus scholarship, understand. Now, if you people don't want this much of scholarship, at least get the rank from 1 to 3, you'll be getting 100% scholarship inside Unacademy. And if you get the rank from 4 to 10, you'll be getting 75% scholarship. What you people are supposed to do in this case, you just have to give the test on 26th of September, 11 a.m. exactly. You'll be getting this one. So use this code in order to get this maximum possible discount, Yawar. Sorry, in order to enroll. When you basically enroll for this one, the link is in the description below. Do it right away. And it will ask for a code. Use this code to basically do that. Next thing is, we have this beautiful feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can definitely post it on Unacademy. You'll get the solution within no time for sure, okay? Even you can ask the unlimited number of doubts. You can ask the doubt any damn time. You'll get the high quality video solution. You will receive the exact match of your questions, okay? Next thing is, there is a doubts and solution option. You need to click on that. You need to basically select the picture from your gallery and upload it. Make sure it should be very clear. It shouldn't be blurred. And you need to crop that particular doubt. It's not like you're saying 5 or 10 questions in one single doubt. No, you just have to basically crop that particular doubt for that, for which you exactly want the answer. Next thing is, you'll get the solution within no time. And these are the do's and don'ts that you need to keep in your mind while you ask this doubt. Exactly. Now, let's basically go for this one. Combination of resistances. What is this combination of resistances? We have studied this previously, combination of capacitors, okay? In mechanics class 11th, over there we have studied combination of springs, understand? Yes. So let's get started. Let's talk about this one, everybody. Okay. This is a very simple topic, very basic topic. I'll be showing you some of the problems afterwards, and some more concepts we'll have to discuss once we get done with this one, okay? So first of all, what is this combination of resistances? We say combination of resistances, what? Different resistances are connected to each other, understand? In a circuit, this is a circuit, different resistors are connected to each other. So that's what we call the combination of resistors, okay? Now, why do we basically study this? We study this if we are, for example, given the complex circuit, okay? This is a very simple circuit. If we are given the complex circuit, in order to find the equivalent resistance, in order to find the current in that complex resistance, in order to find the potential, these things in that complex circuit, we basically study this combination of resistances, understand? So we say there are two types of combinations that everybody knows: series combination and a Perler combination, understand? What is the first thing that you need to keep in your mind? That is nothing but, what is this combination of resistances? Nothing but combinations of resistances. The resistance is connected to each other in a circuit. Different number of resistances connected to each other in a circuit. That's nothing but combination of resistances. Now the point is, why do we study this one? We study it in order to solve. I'll just write it over here. In order to solve, in order to reduce complex circuits. Okay, if I am, for example, supposed to give over here a complex circuit resistance like this, like this, like this, like this, I'll tell you after some time when we'll basically solve the questions. If I ask you to tell me what is the equivalent resistance in that case, so that's why we studied this one, how we can exactly find the equivalent resistance, how we can find the current in each resistance. So that's what we study in this one. That's why we basically study this one. Okay, the first thing, and we say this combination is of two types. The series combination, either it can be connected in series or it can be connected in parallel. So we say series combination, or we say parallel combination. Exactly. Understand? This is what we're gonna be exactly studying in this one in detail today. Every damn thing, every damn question we'll be exactly solving in this one. Okay, everybody understanding? Yes. 1 second. Okay, that's great. Now see, so we have this resistances in series. So first of all, we'll talk about the resistances in series. Say, sir, how do we exactly know that the resistances are exactly connected in series? If I say, for example, this is a circuit over here. If I ask you, are these three resistors connected in series or parallel? So how can we exactly get to know that if these resistors are connected in series? The first thing that you're going to be seeing is that you will check if these resistors are basically connected to each other end to end. Understand? The end of this resistor is connected to this end. The end of this is connected to this end. So we say they are connected in series. The first thing, understand, in this series combination, what happens? The resistors are connected end to end. Understand? I'll just write directly. That's end to end, exactly like this over here. Fine. So the next point in this case is, we'll say, sir, the next point, clearly we can see when we were basically discussing the combination, series combination or combination of capacitors. Now see, this resistance is basically connected to the positive terminal of this battery over here, and the another end of this R3 is basically connected to the negative terminal of this one. So if I ask you very simple question over here, are these three resistors directly connected to this battery? You'll say, sir, no. So this is connected to this one, this is connected from the other end. So all the three resistors are basically not directly connected to the battery over here. So we say potential across these three resistors will be basically different. Understand? If the potential is V, that will be distributed in this one, we say V1, and in this one that is V2, in this one that is V3. Why? Because they are not directly connected to this battery. Understand? If it was directly connected to this battery like in Perler combination, then we say in that case potential will be same across all the three resistors. Understand? So over here, can I say this potential in all the three resistors will be different? Potential will be different in all the three resistors, definitely. Three resistors, I can definitely say it like that. Now what is the third point? You'll say, sir, what happens with the current? You'll say, sir, over here the current will be same exactly in all the three resistors. Why is it like that? For example, if the current I flows like this, understand, in this direction, so we say the I will go in this one, same I will go in this one, same I will go in this one, exactly. Understand? Because they are connected end to end, they are connected in series, so same current will flow exactly over here like we have studied this previously. Understand? So how exactly that's gonna happen? It will take the electrons like this, understand, and that electrons will exactly flow over here, current will exactly flow, so same current will flow through all the resistors. So I can definitely write same current flows through all the resistors. Okay, I can definitely write it like that. Fine. So same current flows through all the resistors. So what happens with the voltage? What happens with the potential? You will say, sir, across this potential will be different, I call that V1. Across this potential will be different, I call that V2. Across this potential will be different, I call that V3. So what happens with the current? You'll say, sir, current is same. Exactly. So I say current in this one will be same I. In this will be same I. In this will be exactly same I. So current in this case is basically same. Now, let's basically, if I ask you, can you basically draw an equivalent resistance instead of these three? You'll say, sir, yes, it is very simple. Instead of these three, I'm asking you one single question, that is nothing but, sir, represent, instead of these three, represent this with only one resistance. You'll say, sir, I can definitely do it like that. It'll be something like this. Okay, so I can represent it with, I call that R equivalent. Understand? So this is the potential, this is the battery over here. Fine. So what is happening over here? Instead of these three, I'm writing only one. Now how can we find the value of this one? Understand? So you'll simply say, sir, it is very simple. In this case, we say potential is basically being distributed. If, for example, this is giving the V potential over here, so that is being distributed in R1, R2 and R3. So can I say in this case, this net potential that is being sent by the battery is nothing but, or simply you just write V only, that is nothing but, and say, sir, that is potential in 1 plus potential in 2 plus this 3V3 exactly. Everybody understanding? Come on in the live chat, give me a thumbs up. Okay, so we say something like this. Now, could you please tell me what will be this V? You might have studied from the Ohm's law, V is equal to IR. Understand? So can I just write over here? In first case, V is equal to IR. For this one, resistance is 1. And for this one, this is V1. So can I just write V is equal to IR1, 100% for the first one. And this I can definitely write it over here. That is V is equal to I. And this is R. What is this R? I just call it the equivalent resistance. Understand? Equivalent resistance. So this will be exactly equivalent resistance. And over here, in the first resistor, what is the current? You are saying, sir, current is I. And what is the potential? You are saying, sir, potential is V1. So can I say that V1 will be equal to current I? Because same current flows through all the resistors. I into what is the resistance? You'll say, sir, that is R1. In this case, resistance is basically R1. What happens with the second one? You'll say, sir, for the second one, we can definitely write this V2 is nothing but that is IR2. And what happens with the third one? Sir, for the third one, V3 is nothing but that is nothing but this IR3, because resistance in R3 is basically, in resistor 3 is basically R3. Fine. So this is the scene. Can you put it over here? Instead of this, can we just write it this? Can we just write IR equivalent? You will say, sir, yes. So this will be I. With this, I'll just write it. So instead of this, I'll just write R, and this will be R equivalent. Okay. And instead of this V1, I'll just put it over here. That will be IR1. And this will be plus. Instead of this, that will be IR2 plus, and it will be exactly over here. That is IR3. So can you just tell me I will cancel because I is flowing same in all the resistors. So this will be R equivalent will come out to be that is nothing but R1 plus R2 plus R3 in that case. So definitely yes, over here I can definitely say it like that. So this is the equivalent resistance in case of this one. This is very simple. If for example the current is flowing through over here, let me just tell you one thing. If for example the current is flowing over here, so what is this resistance? We say, sir, resistance is nothing but it is an opposition to the flow of current. Understand? It opposes the flow of current. If instead of one resistance, I'm putting 1, 2, 3 resistances, so opposition will be more. So means the resistance will be added. More opposition will be exactly added. So R1 plus. So now that current, if I current is flowing through this one, that current has to now basically go through more opposition. So that will be this opposition. R1, R2, R3. So this will be exactly added if this is connected in series. So R1 plus R2, because same current is going through this one. So that will have to travel through more opposition. So R1 plus R2 plus R3. That's why this opposition, this resistance is basically being added over here. Everybody understood? Come on. In the live chat, it's very simple. Not that difficult. You might have studied this in your previous classes, in your 10th class. Okay. Fine. Yes, this is crystal clear. Okay, so basically resistance gets added over here. Resistance gets added over here. That's what we exactly saw. Now, what are the conclusion points that we see from this? series combination. You'll say, sir, the conclusion points are exactly, we can conclude from this one that equivalent resistance is greater than the highest individual resistance. What is that? Now see, if I say, for example, this is R equivalent, it is equal to individual resistance plus R1 plus R2 plus R3. So obviously it will be more than this one, because R1, it is basically addition of all the three. This will be greater than this one, this will be greater than this one, this will be greater than this one. So this is greater of all. So that's what it is saying exactly over here. Equivalent resistance is greater than highest individual resistance. If I say among these three resistances, among these three resistors, this one is the highest resistance. So this will be obviously greater than this one, because this is addition of all. So that's what it exactly saying. Equivalent resistance will be highest, greater than the highest individual resistance. So the next point is current supplied by source is equal to current in each resistor. That's what I explained you initially. Current over here, if the current I is flowing, that will be I in this one, I in this one, I in this one. That will be same through all the resistors. Exactly. The next thing is total potential difference between total potential difference VA क्या लिखा है is shared among, if I say for example total, ये क्या लिखा है इसमें VBA, okay, total potential difference V between A and B, space नहीं छोड़ा. So total potential difference between A and B, if I say for example this is the point A, this is the point B, understand? So total potential difference, what happens with the potential difference? That's being distributed in this one, and in this one. So that's what is written exactly over here, being shared among all the resistance directly in their ratio, like V1 is to V2 is to V3 is equal to R1 is to R2 is to R3. So it is saying that this V1 is basically going in this one. Over here, V2 is basically being shared in this one. V3 is basically being shared in this one. So this is exactly happening in this one. Sir, क्या हुआ? क्यों हंस रहे हो? Love sir is in the chat. Okay, so now let's move on to basically the resistances in Perler. What happens when basically the resistances are connected in Perler? So the first thing exactly we can say over here is, sir, clearly all the three resistances will be connected, are connected to this point A. This resistance is also connected to the point A from the either side, understand, point B. So all the three resistances over here, potential through all the three resistances will be exactly same. Can I say it like that? Yes. yes, yes. अरे पता नहीं क्या लिखता है पीछे से, फिर यहाँ पे डिकोड करना पड़ता है. Yes, everybody hit the like button as soon as possible. Mark the attendance. As Love Sir says, mark the attendance, hit the like button, everybody. So we say in this case, all the three resistors are connected to basically this point A over here. This one end of the battery, I would say. This another end of the battery, I would say. Understand? So if I say, for example, V potential is going over here. If I say, for example, V potential is at this point, same potential exactly over here. So that potential will be across this one. That same potential will be across R2. That same potential will be across this R3. Now what happens with the current in this case? Current will be different. If I say, for example, I current is basically flowing in this one. This is the I current. So I would say this I is basically being distributed over here. In the first one, I would say I1 is going. In the second one, I2 is going. In the third one, I3 is going. This is the difference between that one and this one. Okay. Yeah. This is the only difference that we have exactly over here. So can I say over here potential will be same across all the three resistors? 100% I can definitely write it like that. So potential, directly I'll just, is same across all the three resistors. Understand? What happens with the current? Current will be distributed So current will be basically distributed in this case. Why? If I say, for example, I current is flowing over there, in this case, that is distributed. At this point A, that will be distributed. In this one, I1 will go, in this one, I2 will go, in this one, I3 will go. So what is exactly happening with the potential? We say this one end of this resistor is basically connected to point A, end A. The another end is connected to point A. The third, this end, one end of this resistor R3 is connected to what? This R3 is connected to what? Same point A. Understand? If I say at this point potential is V, so V will be across all the three because all the three are connected to the same end. So at this point, if I say, for example, this is the point B, so can I say over here the potential will be exactly same in all the three? So this is the case, exactly that happens over here. That's all. This is the main difference that you need to basically see. Okay. Now, can you guys tell me in this case, how can we find the equivalent resistance? Very simple. Now see, as if current is basically being divided in R1, R2, R3. So can I say net current I will be equal to, that is current in this one, that is I1, current in the second one, plus this I2, plus current in the third one, that is I3. Clearly, I can definitely say it like that over here. Yes. Now, what is this I? Use the Ohm's law over here. I is V by R. Can I just write V by R? So in the first case, could you please tell me what is the potential across this one? You will say Sir V. Over here it will be Sir V. Over here it will be Sir V. So can you just tell me in this case, because potential is same, all the three these resistors are connected to the same end. So can I say in this case over here, sir, this will be nothing but a V by R exactly. Understand? Where this R is R equivalent. So in this case, what happens with the I1? You will say, sir, that is nothing but this V by R1 exactly, because potential across this is also V. So plus this will be V upon this R2, plus this will be V upon this R3 exactly. Potential upon across this will be V also. So can I just write from this one, that will be 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 exactly. So this is basically what? This happens with the equivalent capacitance in this case. Yes, this happens with the equivalent capacitance in this case. Okay, fine. So this is the scene. Let's basically see what is the conclusion. Okay, this is the conclusion. Fine. That equivalent resistance is equal to lowest resistance even. Understand? Lowest individual resistance. If I say, for example, this is the equivalent resistance, this is 1 by R equivalent. Understand? 1 by R equivalent. So it will be less than the equivalent. It will be less than the lowest individual resistance. Over there, it was basically opposite to that one in previous case. So applied potential difference is equal to the potential difference across each resistance. So the potential difference supplied will be same across all the three resistors that I explained over here. So what is the next thing? Current approaching the junction A will be equal to the current leaving the junction B and is being shared among all the three resistors. This is the most important point. If I say, for example, I is the current that is entering this junction A. This is the junction. Okay. What is junction? Where basically 2 or 3 conductors meet. So this is if I say 1, 2 and 3. So at this point, what is the current that's entering this junction? You are saying, sir, I. So this I is basically being shared over here. I1, I2, I3. And when this, at this point, when the current is leaving, it's again leaving as I. So the amount of current entering the junction A will be equal to the amount of current leaving the junction B. So that is basically over here. Yes. Now we have this question on the screen. Can you guys tell me what is the equivalent resistance? What is the effective resistance between A and B in this case? Tell me what is the equivalent resistance in this case. Okay. That's why I told you, in order to solve complex circuits, we use the concept of series and combination. Okay. We'll use the series and combination concept over here in order to solve these circuits. Okay. So this is the question exactly that we need to go for. Come on. Can you tell me? So we say in this case, see how can we exactly find this? This 3 and this 3, they are connected end to end. They are connected end to end. So can I say these two are exactly connected in series? So we say these are connected in series. Okay. if they are connected in series, what will be R equivalent? You will say, sir, this R equivalent will be exactly, that's this 3 plus this 3. That is 3 plus 3 will be 6 exactly. R1 plus R2. When two resistors are connected in series, the equivalent resistance is what? 1 plus 2. Understand? R1 plus R2. That is this plus this. So can I say in this case, this and this, they are exactly connected in series because they are connected end to end. So this will be in series. So what will be R equivalent? You will say, sir, R equivalent will be nothing but that is 3 plus this 3. It will be exactly 6. Can I just write it like that? 100%. Now, this, instead of this, I'll just make the new diagram. The new diagram is exactly something like this. So this will be first one. This will be first one. This will be second one. This will be the third one. Understand? First one, second one, third one. This is 6. This is 6. This is 6. Understand? So this is A and this is exactly B over here. So this is 6 ohms. This is 6 ohms. This is 6 ohms exactly. Now, can you tell me the effective resistance in this case? You will say, sir, these three are connected in Perler because this one is connected to this, and if you see, this is connected to this, and instead of this I am writing 6, instead of these two I am writing 6. So all these three are connected to the same ends, so they are basically connected in Perler right now. So now how can you find the effective resistance? You will say, sir, 1 upon this R equivalent exactly, so it will be nothing but, you say, sir, 1 upon 6, first one, 1 by R1 plus 1 by R2, that is 1 upon 6 plus, sir, 1 by R3. So can I just write in this case, this will be, sir, 1 plus 1 plus 1, that is nothing but 3 by 6 in this case. So R equivalent I can exactly write in this case, that is nothing but 6 by 3, sir. 100% this is 6 by 3, sir. Now, how much this will be? You will say, sir, this will come out to be 2 ohms exactly. So this is the correct answer over in this one. Now listen to me. I'll tell you the simplest trick how you can exactly find the equivalent resistance with just one single formula. So what you're gonna be exactly remembering, that is nothing but just this is the trick. If, for example, this is 6, this is also 6, this is also 6. Just in case of Perler, you use this one. R equivalent is nothing but, that is this R upon this N. How much is this R exactly? If I say this is, instead of this R, this is 2R, 3R. So just put 3R over here. And how many resistors? So can you just tell me in this case? You'll say, sir, in this case, if we use the same formula, so what is this R equivalent? What is this R? That is 6, 6, 6. Understand? So means R is 6 exactly over here. This will be 6 upon. So what is the N? So 1, 2, 3. So it will be 3. So how much is that? That is 2. Directly use this one. You don't have to do this stuff. So 2 is basically the answer. Fine. Let's move on to the next one. Can you solve this one? All of you. Find current through R equivalent. Understand, you are supposed to tell me what will be the equivalent resistance and what will be the current through that equivalent resistance. The battery is basically given as, the potential is given as this one. Yeah. Come on. Tell me, what is the effective resistance? Okay, you will say, sir, it is very simple. Okay, how is it very simple? First of all, if you talk about this one and this one exactly, they are in series. Understand? Because they are connected end to end. So first of all, you resolve this one. So 2 plus 1 will be how much? You will say, sir, 3. If over here R equivalent is what? R equivalent, I'll just write, is nothing but 3 exactly. This 2 plus 1. Understand? So it will be effective resistance over here. That is nothing but 3 in both of these cases. Fine. Now, this and this, they are connected exactly in Perler. Why? Because this is connected. This resistance, this R equivalent, that is 3, and this 6. They are now connected into Perler. Because this end, they are meeting at the same end. They are meeting at the same end. Understand? So we say they are connected in Perler. Now, you just tell me one thing. If you find the R equivalent between this and this, how you gonna be finding exactly 1 by R1 is equal to between 6 and this 3? You'll say, sir, 1 by R equivalent in that case will be nothing but 1 by this 6 plus 1 by this 3 exactly. Okay, so it will eventually come out to be, this R equivalent will come out to be, that is nothing but 18 by 6 exactly in that case. Fine. So this is 18 by 9 exactly. So this is basically the 18 by 9 exactly. So how much that will be? You'll say, sir, that is come out to be, that is 2. Fine. So this will come out to be exactly 2 over here. So we got exactly instead of this, all this stuff we reduced to this. That is what we call the 2 only. 2 only. Okay. Now you just tell me one single thing. You just tell me one single thing exactly over here. Instead of this, can I make the new diagram? So I'll just make the new diagram over here. So it'll be something like this. Okay. And it will be something like this. This is 120. Fine. Okay. इसको erase करता हूँ. It'll be something like this. Okay, yes. And then we can definitely write it instead of, yeah, this will be exactly this 4. And this we basically reduced it to 2 only. So this is over here. We can definitely write it something like this. Okay. We can definitely write it something like this. Fine. Everybody is clear with this one. Everybody is clear with this one. I need to know in the live chat. Okay. Just put all of these values. That is 120 exactly. This is 4. This is 4. And this is 3. And what is the effective resistance of this stuff? That is coming out to be 2 only. Understand? So it will be 2 only. So definitely you can write it over here. That is this 2. And this was already this 4. This 4. And because of this, instead of this, I'm just writing the 2 over here. Fine. So now, can you just tell me this one and this one exactly? They are connected in series. They are connected in series 100%. They are connected end to end. Yes. So instead of these two, can I just write 6 exactly over here? So what will be the new diagram? You will say, sir, the new diagram will be exactly something like this. So it will be something like this only. So this has to be the new diagram. And because of this, it will be 6 only. So I'll just write something like this. Okay. Afterwards, that will be connected to Perler. So because the resultant of this effective resistance of these two, it will be 6. And this will be what? This will be 4. This will be 4. And this will be 120 volts exactly. Fine. Okay. Yes. So what is the net afterwards? What's going to happen? You'll say, sir, afterwards, it will be this one and this one in series. So what is the effective resistance of both of these two? You'll say, sir, that is nothing but 2. 1 by R equivalent is equal 1 by 3 plus 1 by 6. So because of these, it will be 2 only. So finally, it will be nothing but, so we can definitely write it something like this. This is 4 and this is 4. And because of these two, it will be 2 only. This is 2. This is 4. This is 4. This is 120 volts. Can I just write it like that? 100%. Now 4 plus this 2 plus this 4, because they are all connected in series. So how much will be R equivalent in that case? We'll say, sir, this R equivalent will be nothing but that is 4 plus 2 plus 4. It will come out to be 10. So can you please tell me what will be the current through this R equivalent? You'll say, sir, this current will be exactly that is V by R 120 upon this 10. That is nothing but 12 amperes. Fine. Done. Yes. Let's move on to the next one. Now, can you solve this one? Over here, I'm going to be showing you basically one more method that will help you to solve these circuits. Okay. Now, listen to me very carefully. If I say, for example, this is the circuit over here, we'll use what method? We'll use potential method. Potential trick to solve this one. See how that's gonna basically work in this case. If you have something like this, listen to me very carefully. Okay, listen to me very carefully. If I say this is point A, this is point B, we need to basically find the effective resistance. We need to find the equivalent resistance in this case. If I say, for example, this is R, and this is R over here. Fine. All the three are basically R over here. Can you just tell me, if I just go from this point to this point, at this point, the potential at this point will be same at the potential at this point. Call that A, call that V, X, Y, Z, whatever it is. So it will be the same at potential at this point because this is directly going like this. So at this end, I call the potential, I call the same A. Okay, let's give it a name as A. So now travel from like this, go at this point. So can I say at this point also potential will be same? 100% the potential will be same. Now go to the other end. So at this point, potential is basically B. 100%. Now from this point, go something like this, go. At this point, potential will be, that is what we call the B. Understand? from the other end. You say potential at this point is V, potential at this point is 0, so at this point will be 0, whatever it is. I am just basically mentioning only the 2 points exactly over here so that you'll get the feel. Now, what are the two? There are only 2 points that I can see in the entire circuit. That's A and B. That's A and B. Understand, the potential at this point is A, at this point is same A, because they are connected by a normal wire. And this is also at this point is B, at this point is exactly B. So I'm just writing it exactly over here. Fine. Now, what I'm basically saying, you draw these 2 points. Draw these, draw A and B only. These 2 points only, understand? Draw A and this B only. Fine. So first of all, you will draw basically this A. So this is basically A. So this is what? This A. Fine. So what are the resistances that are connected between A and B? Just draw all of those resistances. That's what I am supposed to tell you. So this is what we call the A exactly over here. And this is what we call the B exactly over here. Okay, this is A and this is B. Can you draw all the resistances which are between A and B? Say, sir, between this A and B, this is the resistance, what we call this R1. Yes. This is this, I call this as R. Okay, this is the resistance of this is R. Now, this resistance is also between A and B. So we'll draw this resistance also. So this is what? R. So this resistance is also between A and B. Yes, we can draw this one also. It will be something like this. Now, what is the resistance of this one? Can you find now the equivalent resistance of this entire circuit? It is very simple. So I can say this R equivalent will be nothing but R upon this N. So what is the value of this R? That is nothing but R only. Upon this N. What is the value of this N? 1, 2, 3. So can I say this will be R by 3 exactly in this case? 100%. So R equivalent is coming out to be R by 3. Everybody got this? Just mark the points exactly. Understand? Just mark the points. Then you're going to be basically solving these questions. Now we have the next question. Okay. This was the, I used the potential method initially in the previous case. Fine. Next we have this one. Can you solve this question exactly by using this potential method only? Come on. I just need to know in the live chat itself. If you can solve this. Okay. Same potential method you need to basically use over here as well. Okay. Use potential method exactly in this case. Fine. That's how you're going to be basically solving this one. Everybody, I need to know what is the answer of this one. You'll say, sir, it is very simple. The solution of this one. This is the point A. This is the point B. Understand? Now go from this point A. Point A. At this point, I'm saying the same potential exactly A. Now from this point, this point, this point, this point, exactly at this point, the potential is same. At this point, the potential is same exactly at this A. Understand? Can I just say it like that? At this point, the potential is exactly same. I would say A, V, whatever it is. Now go from this point, this point, this point. At this point, the potential is exactly, this is, I would say, for example, same potential. These are the points I am marking. Okay. If I say V over here, 0 over here. Just you need to understand the concept. So now go from this point to this point, and this is the point B. At this is the point B. They are connected between these 2 points. Now this is the different point. So I call this point exactly X. You call this point exactly the same X. Understand? From this point to this point. Can I just write it like that? How many points I can exactly see in the entire circuit? You will say, sir, only 3. So draw all the 3 points. So you will say, sir, the first point is exactly, that's what we call the A. And the second point I would call that is nothing but X. And the third point I would call nothing but that is B, sir. Okay. Now tell me, what are the resistors which are connected between A and X? So this is connected between A and X. So you'll say, sir, this will be something like this. That is nothing but 2 ohm. Fine. Sir, this is connected between B and X. Okay. This is connected between B and X. So it will be something like this. Fine. Sir, this is connected between A and X. Okay. I'll just write it something like this. So this is connected between A and X. This is connected between A and X. I call this as 2. And sir, this is connected between B and X. So it will be something like this only. Okay. This is 2. This is 2. So we are done with this. 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 Now what is the next thing? So that is this one. So this is the 2 ohm. So this is connected between A and B. You'll say, sir, if this is connected between A and B, I'll just mark it something like this. It is something like this. Can I just say it like that? 100%. So this is also 2 ohms. Now, can you solve this one? It's very simple. It says, sir, this one and this one are connected in Perler. This one and this one are connected in Perler. So can I say over here, this R equivalent will be simply, that is nothing but, this R equivalent in this case will be nothing but, sir, this R equivalent will be, that's R by N. That's R by N. That is nothing but 2 by 2. 2 by 2, that is coming out to be 1 only. So in this case, it is 1. In this case, also it is 1. In this case, it is also 1. So 1 is basically R equivalent exactly over here. If this is 1, this is 1. So can I resolve it to basically to the new circuit? This is 1, this is 1. Understand? So 1 plus 1, that will be 2. So final, it will be, see, this is 1, this is 1. So 1 plus 1 exactly, that will be 2. So 2 plus 2 and 2 are basically in Perler. In that case, how can we solve this? So you'll say, sir, it will be something like this. So this and this is 2 and this is 2. Fine. Now, can you tell me over here? You'll say, sir, that will be nothing but R equivalent in this case will be nothing but, so it will be R by N. So that will be R is nothing but 2 by 2. It will come, it's coming out to be 1 only. 1 is the correct option in this case. Fine. Done. Everybody. Yes. Let's move on to the next one. Can you solve this exactly? Can you solve this exactly? You need to basically use the same method, potential method, okay? Use the same method exactly over here as well. That is, use potential trick exactly. Fine. So how are we gonna be basically solving this? Now see, if I say at this point, I call this point A. This is point C, this is point B, point B. So they are directly connected to each other. So instead of this, I would say over here, the potential will be V. At this point, I call the same V. Or simply, instead of this D, instead of this C, you just write A over here. Same A, you just write over here as well. Understand? At this, if I mark the point A. So at this point, if I say this is nothing but point B, over here, I call this also as point B. Same potential, same potential. Can I just say it like that? 100%, it will be something like this. Okay. Now, so this is A, this is A, this is B, and this is B exactly. Now, exactly I can see in the entire circuit, there are only 2 points. So that is A and B. Can you just draw all of these resistors between A and B? 100%. You will say, sir, this is the point A exactly, and this is the point B exactly. I can definitely say. Now, this one and this one are exactly between A and B. These two resistors, I'll just take these two resistors only. They are between A and B only. So I'll just take as it is. Okay. Don't get confused over here, sir. This is the middle point over. So I'm just taking both of these resistors, but drawing between A and B only. So this is between A and B. Now take this arm. So I'm taking basically this arm. This is also between A and B. So it'll be something like this. Okay. Now I'll take this arm exactly. So it is also between A and B. So it will be something like this. Now I'll take this arm. So this is also between A and B. So it will be something like this. So it is something like this. Okay. So all of these are basically R, R, this is 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 R. Now these two are connected in series. So can I say instead of these two, I'm just taking R plus R, that is nothing but 2R. So it will be nothing but, I'll just write that is 2R exactly. So instead of this, I'll just write, okay, this is 2R, 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 2R exactly. Fine. So can I just say further, if this is 2R, this is 2R, this is 2R, this is 2R, can you just tell me R equivalent will be nothing but how much? You'll say, sir, that is R by N. So what is the value of R over here? You will say, sir, that is nothing but 2R, because this is 2R, 2R, 2R. So it will be 2R upon how many? 1, 2, 3, 4. So it will be 4. So can I say this will be nothing but R by 2 exactly in this case? So this is basically R by 2. Everybody got this one, man? Now we need to basically talk about this cell, what this cell is all about. Okay. Fine. I hope everybody understood. Yes. Now see, we say it's a device which provides the electrical energy to all the components of a circuit. In case of capacitors, we have basically studied this stuff. That is, if I say, for example, there's a battery over here, and this is connected to what? This is a Perler plate capacitor. Exactly. This is another Perler plate capacitor. So this is a positive terminal, negative terminal. So what this battery was exactly doing in this case, this was taking the electrons from this plate and was placing it onto the another plate. So this was getting positively charged, this was getting negatively charged in that case. Okay, previously we have studied this in case of the capacitors. Or this was taking the dq charge from this one, placing on this one, so this was getting positively charged, negative charge. So what exactly this was doing? This was doing the work done, and we called that work done. This is nothing but supplying the kind of energy. Understand? This was supplying that work done, was basically being stored as energy over here. So I can say, in other words, this was exactly supplying the energy. It is a device which provides the electrical energy to all the components of a circuit. These are the components. Over here, we don't have to talk in terms of the capacitors. We are basically learning the resistances. So we say, if I say, for example, this is the resistance exactly over here. Okay. So this battery will basically do what thing? It will basically supply the energy that will be stored in all of these, I would say, electrical components. Now the point over electrical elements. Now the point over here is, what exactly is going to happen? This cell will exactly supply the energy to the charge. Understand? This will supply the energy to the charge, and that charge will basically flow and waste that energy in this resistor. Understand? यहाँ पे लिखा है क्या? So we say cell supplies energy to the charge which wastes in the resistor. Understand? So basically what happens exactly? This cell gives the energy to the charge, and that charge basically flows, and when that charge flows, that basically wastes that energy in this resistor and then comes back to this cell. Again it takes the energy and wastes over here. So this is how exactly the energy is basically being transferred to the different elements of the circuit over here. Understand? So cell does not supply the charge, it makes the charge to flow. It only basically makes the charge to flow. It gives the energy to the charge, so because of that energy it basically flows. So we say cell maintains the potential difference which forces the charge to move in a circuit. So this cell, we say it provides the potential difference. We say it maintains the potential difference due to which that charge basically keeps on, that will keep on flowing. Like in case of the capacitor, we were saying on the first capacitor, on the one plate, it was higher potential. On the another plate, it was lower potential. So because of that potential difference, charge was basically flowing. So this is what we call the cell. This is what we call the cell. Okay. This battery cell, this is what we call the cell. Understand? This is the work of a cell. Everybody got the feel? Keep this thing in your mind. This cell doesn't supply the charge. Okay. It just makes the charge to flow. Understand? Or you can say it supplies the energy. Understand? Because cell doesn't produce the charge, it doesn't supply the charge. Next thing is this EMF. What is this EMF all about? Listen to me very carefully. People say it's electromotive force, but it is not a force exactly. That's a name only. Understand? This is a name only. It's not the electromotive force. So we say this is something like this. This is a positive, this is a negative. Hey, you both are from JEE 2022. Ria, you are from JEE 2022, and this Akash. So this is positive and this is negative. I can definitely say it over here. Okay. So you just tell me one single thing. It is the potential difference between the electrodes of a cell when no current flows. Understand? Listen to me very carefully. We say this is the potential difference, or this is the basically potential difference when no current flows or when no element is connected to the circuit. You can basically say it like that as well. Understand? I'll make you understand what this exactly is. Okay, okay, okay. 2022. Okay, that's fine. We're bringing a next level series from first onwards. Okay, we're bringing a next level series from first onwards. So that's why. You'll get to know about that. So we say it's called electromotive force, but not in a force exactly. So it's a potential difference between the electrodes of the cell when no current flows. Listen to me very carefully. If I say, for example, this is a cell over here, understand? There is no element connected to this cell, understand? So when there is no element connected to this cell, so I would say in that case, no current will exactly flow, okay? Yeah, I have told you previously how exactly current flows. It drags the electrons from one of the plates in case of the capacitors, and that will basically, when that electron flows and the current flows in that case. So we say over here, no current flows. It's something like, for example, we have that cell that we buy from what? From a shop, understand? So that's something like this, okay? Very small, that we use in our like AC remotes, in our some TV remotes. So that's what we call basically the cell in that case. No, when no current flows. So this is what we call that EMF only, understand? So what is this EMF? You say this EMF is nothing but over here, what is the potential difference? In previous case, we were saying that if, for example, this is a cell, I am connecting some elements to it. So then the current will exactly start flowing. In that case, when current exactly starts flowing in that case, so we say over here that voltage, that potential difference created across these two ends, it will be something else. That's what we call the terminal voltage, that I'll tell you after some time. So if I say no element is basically attached to this one, so no current is flowing, but still this will have the potential difference across these are terminals only. So that potential difference is nothing but EMF. This is, see, it is simply the cell, the battery only, understand? So how much is the potential difference across the terminals of the battery? You'll say, sir, 5 volts, 10 volts. That's what we call the EMF. Now, if you connect that battery to something, the current will start flowing. In that case, you'll say, sir, there is a potential difference across the ends of that element, that resistor, whatever the element is, that capacitor. In that case, that voltage is what we call the terminal voltage. So this EMF is simply when no current flows, no circuit element is basically connected to this battery. It is just a battery. How much is the potential difference across the terminals of the battery? I say, sir, this much. If I say, for example, when you buy this cell from the shop, you getting me what I'm trying to say? If I say, for example, you buy this cell from the shop, over there it is mentioned on this battery that is 5 volts, 6 volts. What does that mean? That means that is the EMF of this one. Over here it is mentioned that is 5 volts EMF. Understand? So what is that? That's the potential difference across the terminals of the battery. So in that case, we say that is what? This EMF is what? The potential difference across these two terminals when no current flow, when nothing is basically attached to this circuit. So this is what we call the EMF. Normal potential difference. Understand? Normal potential difference when no current flows or when no element is connected to this one. Understand? When we basically use afterwards this battery in any remote or in anything, understand? It doesn't give exactly this much of potential difference. Why? Because of the internal resistance, understand? So it doesn't give this much of potential difference. So the amount of potential difference afterwards it gives when it basically is connected to any circuit. So in that case, that voltage is what we call this one. Yeah, I'll tell you terminal voltage after some time. Yeah, this is just simply the potential difference across between these terminals of the battery. Understand? When no current is exactly flowing, nothing is connected to this one. Yes. Now see, we need to talk about internal. Okay, before this, let's talk about this. Terminal voltage. What is this terminal voltage all about? It is the potential difference across the terminals of a cell when it is connected to an external circuit. Understand? In this case, if I say, for example, this is the cell. Understand? When the cell is basically connected to an external circuit, if I say, for example, the resistor over here, fine, positive, negative. So current will exactly start flowing. For example, the current is exactly going in this one. So over here, If I say how much is the potential difference across the ends of this resistor, you'll say that is what we call the terminal voltage. Understand? So this is between this and this. If no current is flowing, nothing is connected to this one, that is what we call the EMF. Simple. When you basically buy it, that cell from the shop, that is nothing but EMF. How much is the potential difference across this one at that point of time? That is nothing but EMF. When you use that in any circuit, when you use that in any electrical device, afterwards current will start flowing. That cell will basically start working. That cell will provide the potential difference. That potential difference afterwards, which is provided, that is nothing but the terminal voltage, because afterwards the current will start flowing. Understand? The current will start flowing. So that's what we call the terminal voltage in that case. And this terminal voltage, we say it is lesser than that EMF. Why? Because over here, when the current starts flowing, another thing generates. That's what we call the internal resistance. That internal resistance reduces what? The current flow, internal current flow. That's why I'll tell you after some time what exactly. So this is what we call the terminal voltage. When current flows in the circuit, in that case, how much is the potential difference across the ends? That is what we call the terminal voltage. These are basically bit complex terms. That's why I'm making you understand in a better way. 1 second. I just need to mute this. Now we have this relation. Okay. We have this internal resistance. What is this internal resistance? It is, for example, this is a battery. Okay. This is the positive terminal and this is the negative terminal. Over here, this is the resistance created internally. Understand? I call it, we represent with the small r. This is nothing but internal resistance. Now see, when we basically listen to me, how exactly I'm gonna basically make you understand this one. 1 second. Now see, if I say, for example, I'm buying that cell from any shop. Understand? I'm using that cell. On that cell, it's mentioned it will provide 5 volts of potential difference. Understand? Or V volts of potential difference. And because of that V volts of potential difference, it will provide I current. Understand? Because when there is potential difference across the ends of a conductor, there will be current. We have studied this in Ohm's law. Okay. So it is saying that because of that V volts of potential difference, it will provide I current. Now, when we basically are using that, when we basically use that, we observed, understand, we observed that it is providing how much amount of potential difference? Only we will say V by 2, half of that only, for example. So it is not providing the actual V. And we can say, we basically check, it is providing only half of the current. Understand? In that case. So why is it like that? So means when it was that V, this is a cell, whatever is mentioned on this one, for example, that V volts it will provide. This is what we call the EMF. It is correct. Understand? When no current flows through the circuit, in that case, we say this is what we call the potential difference. Understand? Afterwards, when we are using it, afterwards, what is happening? It is providing less potential difference than this one. That's what we call the terminal voltage. Why that exactly happens? It is because of the internal resistance. Understand? It's when we are using this one, it is because of the electrolyte. You have to go in the chemistry. You might have studied this one. Okay. It is the obstruction offered to the path of a current due to the material of the electrolyte of the cell. Understand? Whatever is the electrolyte inside the cell, it is because of that. Understand? This internal resistance is because of that. This resistance is basically opposition to that current flow. That's why we say there will be less potential difference. Because of that less potential difference, we say there is less current flow. Understand? So this is what we call the internal resistance. This is inside the cell only. That's what we say internal resistance. I hope you got the feel of this one. Let's move on to this one. This I have told you previously, okay? When we were basically using those sign conventions, I told you to remember these sign conventions. This is nothing but that only. Understand? Relation between EMF and V. This I have told you in the last lecture itself. Between this A and B, when battery is not in use, we say what? Potential difference is what? Nothing but EMF. Understand? Across AB, that is nothing but E only. Okay, we say that is nothing but E only. Understand? Okay. Over there, ask your chemistry teacher what is the exact process. of this internal resistance in that case. Now see, so we say across this one, when no current flows through the circuit, we say in that case, what is the potential difference across this one? That is EMF of this one. Understand? That's what we call the EMF, and that we represent with this one only. So we say afterwards, when battery is getting discharged, understand, this is basically supplying the energy. In that case, could you please tell me how much will be this? I have told you this previously in case of that potential drop and potential gain. Can you tell me in that case? Can I say in that case this will be nothing but over here, this will be VAB. It will be nothing but this E minus IR exactly over here. Understand? Don't look at this from A to B. I'm talking about. So if you go from A to B, this is what? This is potential drop, and this is the direction of current. So in case of resistor, you are supposed to basically check the direction of current. This is opposite. So it will be negative of what? It is negative of what? IR. If it was like this, it was in this direction. That means this was potential drop. We take potential drop as positive. Previously, I have told you this. Okay. So in this case, we say what? This is E minus IR, or simply you just remember, if this is the direction flow, so in that case, we say this is supplying the energy. This battery is supplying the energy. So battery is getting discharged. Battery is getting discharged. That's E minus IR. Understand? That's why. So how much basically it is supplying to this one? That is this E minus that IR. And in this case, when battery is basically getting charged, means there is some external battery that is supplying the energy to this one. That's why the direction of current is basically in this direction. You will say over here, how much will be this? VAB. You will say, sir, that is nothing but VAB, potential across A and B. You will say, sir, that is nothing but, you are going in this direction. So you will say, sir, that is E plus this IR. Why are you taking again this E? Because this is a potential drop. And if we look at this from this point of view, battery is getting discharged. Somebody else, some other higher battery is basically sending the charge to this one, energy to this one. So in that case, that's why. So over here, this is from positive to negative. Electric field will be in this direction. So potential decreases in the field in the direction of electric field. We say in that case, we take this as positive, potential drop as positive. This I have showed you in the last lecture clearly. So this will be in that case what? When battery is basically being discharged. Fine. This was all about today. Thank you, ladies and gentlemen. You can definitely follow me on Unacademy. This is my username. Everything clear? So follow me over there. That's my username. And apart from this YouTube platform, we have our own platform. Okay, that's Unacademy's. Unacademy's platform. Now, over there, country's top educators are teaching you. In order to, if you want to basically learn from those top educators, you need to take this plus subscription. Okay. For that, in that plus subscription, you will be getting live classes, weekly tests, structured courses, unlimited access. Understand? What is this live classes? Every single day, you will be watching the live classes from different top educators over there. Okay. If you people want to boost your rank in your upcoming JEE, you should definitely go for this plus or iconic, because recently you might have seen what Unacademy has produced in JEE 2021. Okay. AIR1 was definitely from Unacademy only, 1887, and so many people with 99.5 and above percentile, they were all from Unacademy. So if you people want to basically be in that category, then take this plus and iconic subscription. Okay. Yeah, over here. In this case, from positive to negative, this is what? Potential drop. We take that as positive. Potential drop, I told you yesterday, we take that as positive. Understand? And over here, we are going from A to B. In case of this battery, we don't basically check the direction of this I. And over here, if you are going from this point to this point, from A to B, the direction of current is basically this. So in that case, we say this is the potential drop. Current flows from higher potential to lower potential. In that case, forget about this battery. Talk about this only. Understand? That's why. Go to that previous lecture. Okay. That will give you the proper feel of this one once again. So we say this is unlimited access. This is the unlimited access exactly. And in this unlimited access, you'll be exactly getting, you can create your own batches. Understand? Like, for example, if there are so many top educators who are teaching you different batches, but you like this educator in chemistry, in physics, you like that educator, in mathematics, that one is your favorite educator, you can pick up all these 3 educators and create your own batch. That access you will be having inside this plus only. Understand? Yes, bye. Yes, I'll be sending that in the Telegram itself. Every day I send the notes. So this is the personal guidance, okay? This all comes under the Iconic subscription. In this Iconic subscription, you'll be getting all the benefits you get in Plus and some of the extra benefits like personal guidance, test analysis, experts guidelines, study material, study planners. Test analysis is once you are done with your test, afterwards you will have to analyze your scores, okay? So that comes under the test analysis. This is the personal mentorship. There will be personal mentor will be given to you if you take this Iconic subscription. He will be guiding you throughout your exam personally. And this is the study material that will be sent to you, study planners, experts guidelines as well. Next thing is, you can take this Plus subscription for like 3 months, 6 months, 12 months, 18 months and 24 months. If you want to try it, how exactly it looks like, how are the teachers providing the stuff over there, I suggest you to basically take it for 3 months if you want to try it, okay? If you already knew who are the top educators teaching over there, then go for these subscriptions. Now, if you want to check, go for this one, then take the higher subscription. If you like it, if you don't, then it's okay. And EMI options are available as well, okay? You don't have to pay the entire amount at once. You can pay it every single month. Next thing is, you can take this Iconic subscription for 12 months, for 18 months and for 24 months, okay? This is my code Yawar. You can definitely use it in order to get the maximum possible discount. Use this code. And these are basically the batches which Unacademy has launched recently, in which countries top educators are educating you. They are basically teaching you. You need to go for this. You need to check this in order to boost your rank. This is the before price hike. This is after price hike. This was the price before. This is before price hike, after price hike for 24 months, 12 months, 6 months, 3 months exactly. Go for this one. Okay, use my code to get the maximum possible discount as soon as possible before these offers end. Okay, this is the Mega JEE Plus, Mega Combo JEE Plus CBSE. This is for 12 months. You'll be getting 15% plus 10% off. 24 months, 20% plus 10 months off, 10% off. Use my code to get this much of maximum possible discount. Next is, this is the biggest scholarship test for IIT JEE aspirants, okay? If you people want to learn free on Unacademy, then go for this scholarship test. If you get the rank from 1 to 3, you'll be getting 100% of scholarship. From 4 to 10, you'll be getting 75% of scholarship. Use my code Yawar, okay? In order when you basically enroll, even you can win up to 4 crore plus scholarship. We have this feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can ask it on Unacademy, okay? You'll be getting unlimited. You can ask unlimited number of doubts. You can ask the doubt any damn time. You'll get the high quality video solutions, that too in English as well as in Hindi language. You'll receive the exact match for your questions. And this is the doubts and solutions exactly. You need to click on this one. Afterwards, you need to select the picture. Make sure that picture should be very clear. It should not be blurred. And once you basically select that, you need to crop that particularly. It's not like you'll send 5 or 10 doubts in one single photo, no. And ask this doubt over here, you'll get the solution within no time. These are the do's and don'ts that you need to keep in your mind while you ask this doubt. Thank you so much. It was really nice interacting with you. Subscribe to this channel, hit the bell notification, like and share. Thank you so much. Thank you so much.